All right, let's just jump right into one of the biggest questions you can possibly ask. What would actually happen if you could travel at the speed of light?
I mean, really think about it. Would time just grind to a halt for you? Would you see the entire universe just flash by in a single instant? It's something we've all dreamed about, and let me tell you, the real answers are way stranger than you can imagine.
And what's so amazing is that this isn't just guesswork. We actually have the rule book for this whole thought experiment, and it was written over 100 years ago by Albert Einstein. So let's see what it says.
Okay, before we even think about hitting the gas, we have to start with the one single, non-negotiable law of the universe. Seriously, everything else we're about to talk about is built on this one idea. That's it. That's the cosmic speed limit. And it's not just a suggestion or a technological hurdle. It's a fundamental rule of space-time itself. If you have mass, and you do, you can get closer and closer, but you can never, ever hit the speed of light. And that's the real question, right? We can't actually get there, but we can imagine pushing our ship to, say, 99% of light speed, then 99.999%. And it's on that journey, as you get ridiculously close to the limit, that reality itself starts to, well, it starts to break.
All right, so here's the first mind-bending thing that happens. As you accelerate, it's not the metal of your ship that starts to warp. It's the very fabric of reality, time and space.
And this isn't just a feeling. It's a cold, hard, physical fact called time dilation. Think of it like this. You're always traveling through this thing called space-time. The faster you push your speed through the space part, the slower you automatically move through the time part. Your watch would literally tick slower than a clock back on Earth. And this effect gets really dramatic, really fast. A trip to our nearest star, Proxima Centauri, would take 4 years from Earth's point of view. But for you, inside that ship, it would feel like just 7 months. If you pushed even closer to light speed, those 4 years could shrink down to a few minutes. You could do a round trip and come back to Earth having aged a few hours, while everyone you knew was years, maybe decades older.
But it's not just time that gets weird. Space does too. From your seat on the ship, the 4 light-year distance to that star would actually shrink. The universe literally squishes itself in front of you. So if time and space are this flexible, why can't we just push a little harder and hit that final speed? Well, it turns out the universe has a pretty clever defense mechanism to stop you.
The brilliant physicist Richard Feynman explained it perfectly. You know inertia, right? It's just how much something resists being pushed. Well, as you go faster, your inertia, or what we call relativistic mass, starts to go through the roof.
This creates this impossible feedback loop. You hit the accelerator, you get faster, but that makes your ship heavier. So now it's harder to push. So you need more energy to get the same amount of acceleration. To get that last little push to reach the speed of light, your ship would become infinitely massive, and you'd need an infinite amount of energy. It's game over.
And listen, this isn't just some crazy theory. In particle accelerators like the one at Caltech, scientists are doing this every single day. The electrons they accelerate become 2,000 times more massive than they are when they're sitting still. They have to account for this, or their experiments just wouldn't work. It's real. Okay, so time slows down, space squishes, and we can't ever quite hit that final speed. But what would you actually see out the window? What does the universe look like when you're going that fast?
First things first, you can forget all about those cool-looking streaks of starlight you see in the movies. The reality is, well, it's a lot weirder and, frankly, way cooler.
It all boils down to an extreme version of something you're already familiar with, the Doppler effect. As you race towards the light from stars in front of you, you're basically ramming into the light waves, compressing them. This shifts their color to blue, then ultraviolet, and eventually into high-energy X-rays that your eyes can't even see. The light from stars behind you gets stretched out and shifts to red.
So what does that all mean? It means the stars in front of you would just vanish. Their light would be too high energy for you to see. But at the same time, the faint, invisible afterglow of the Big Bang would get compressed into a blindingly bright grayish-white circle right in front of your ship. Everything else around you would be pitch black. Your view of the entire universe would become a single, brilliant tunnel of light.
So far, we've talked about what it's like to get close to the speed of light. But what if we change our perspective? What is the universe like for something that's already there? What does light itself experience? See, a photon, a single particle of light, has zero mass. Because it's massless, that whole infinite energy rule just doesn't apply. A photon is born traveling at the speed of light, and it dies traveling at the speed of light. It literally knows no other speed. Now get ready for this.
A photon's journey from the sun to your eye takes about 8 minutes from our perspective, right? But for the photon itself, that journey is instantaneous. It is emitted from the sun and absorbed by the Earth at the exact same moment. Zero time passes for it.
This is the ultimate consequence of Einstein's ideas. From a photon's point of view, time is completely stopped. And because of that, all distances in its direction of travel shrink to zero. A photon experiences its entire trip across the universe, from the instant it's created to the instant it's destroyed, in a single, timeless, dimensionless moment.
Which, of course, brings us to a huge final question. If our entire experience of time and space is just a side effect of how slow we're moving through the cosmos, then what is reality, really? It seems the universe doesn't have one single here, or one single now. The faster you go, the more you realize your reality is just one of many.